So just try this problem first, and then I'll explain it. Okay, so this is a strong base, and that's because it's a bad nucleophile, right? Because it's a bad nucleophile because it has a lot of sterics. It's very sterically hindered because there's 3 CH3s. So that makes it a strong base. Now, strong bases are E2 reactions, right? And the key thing about E2 reactions are that they have to be anticoplanar. Now, for anticoplanar, we have to decide where the double bond will form, right? Because E2s create alkenes. So for anticoplanar, that means that the hydrogen and the leaving group have to be opposite each other, right? So we have to make sure that this bromine is either opposite from this one or this one. And so let's look at this case, right? So in this case, we can't actually tell if it's completely opposite. And it looks like it isn't because it's pointing down and this one's pointing up. And over here, this one's like slanted and this one's perfectly straight. So let's do a ring flip, right? And this, what I drew here is the cyclohexane, which it's based off of, the original one, right? So then I can do the ring flip. Notice how this one's different than this one. So I switched it. In this case, you can clearly see which hydrogen is the best, because in this case, this one's completely vertical and this one's completely down, right? So that means it's anticoplanar because it's completely opposite each other. This one's completely down, this one's completely up, so it's completely opposite. That means that this side has to be where the alkene is formed, the double bond. So the hydrogen will take the base will take away the hydrogen right here and form the double bond right there, right? So if you wanted to see the cyclohexane form, it would look like this. And so finally, you would have your double bond right here. Remember to keep your CH3 right there and then your ethane right there. So the key thing for here is just to make sure that your E2 reaction is anticoplanar. In this case, we can't really tell if it's opposite, but when we do a ring flip, we can see that the hydrogen is straight up and then the bromine is straight down. So that means that it has to be E2 for this side. So that's why the double bond forms right here. So I hope that helped, and thanks for watching.